You type a short sentence, and a picture appears, one that nobody has ever drawn before. So where does it actually come from? Here's the strange part. The AI does not paint pixels onto a canvas. Instead, it starts from messy static and slowly removes the noise until an image is left behind. To pull that off, three things happen. Your words become meaning. It starts from pure noise, then it denoises step by step. Let us look inside. First, the training. The model was shown huge numbers of images, each paired with a caption describing it. From those pairs it learned how words relate to pixels. And the scale is enormous. Billions of image and text pairs from across the web. It does not keep copies of any of them. It only keeps the patterns it found. Now your turn. When you write a prompt, the model converts those words into a list of numbers, a meaning vector called an embedding that captures what you asked for. That little vector is the compass for everything that follows. At every single step of drawing, the model checks back against it, steering the picture toward your words. But here is where it really begins, not with a blank page, but with pure random noise. A field of static, like an old television tuned to nothing. Why start from chaos? Because that random noise is a seed, and almost any image could be hiding inside it. Your prompt is what decides which one comes out. The core trick is one small step, repeated. The model looks at the noisy image, predicts which part is just noise, and subtracts a little of it, leaving something slightly cleaner. Do that over dozens of tiny steps, and the picture slowly comes into focus. First raw static, then a blurry shape, then sharp detail, guided the whole way by your prompt. Watch it happen. With each pass, a fraction more noise falls away, and the image you described rises out of the static, appearing as if from nowhere. So why does removing noise create a picture? It comes from how it learned. In training, it took real images and gradually added noise until they were pure static. Then it practiced doing the reverse, undoing that noise to recover the original. Generating a brand new image is simply running that learned process backward from noise to picture. There is one more trick for speed. Instead of denoising millions of raw pixels, the model works in a compressed code called the latent space, then decodes it back to a full image. A full picture is millions of values, but the latent is just a tiny summary. Fewer numbers means far less work each step, so the image arrives much faster. You also get a dial called guidance, how hard the model sticks to your prompt. Turn it up and it obeys more literally, but push it too far and the image breaks into artifacts. So it is a balance. Too low and it wanders off your prompt. Too high and it turns harsh and ugly. The sweet spot sits somewhere in the middle. Remember that starting noise? It comes from a seed. The same prompt with the same seed gives the exact same picture every time. Change the seed, and you get a completely new one. This also explains the famous failures. Hands follow many tiny rules and vary wildly, and text needs exact letter shapes, and fine detail is the first thing noise blurs away. So, 3 ideas to remember. Your words become a meaning code. The image starts from pure noise, and the model denoises it step by step, always guided by your prompt. And that is the magic. From a handful of words to a brand new image, painted not by adding strokes, but by patiently removing noise. Thanks for watching Pixel Science. If you enjoyed this, follow along. There is a new video every week.